Next, the Prandtl number, symbol Pr, named after Ludwig Prandtl, the father of modern aerodynamics. What does it tell us? Prandtl number compares two molecular transport properties: momentum diffusivity, how fast momentum spreads through the fluid, that's kinematic viscosity, nu; thermal diffusivity, how fast heat spreads through the fluid, that's alpha. Pr equals nu over alpha equals momentum diffusivity divided by thermal diffusivity. Or using other properties, Prandtl equals mu times Cp divided by K, where mu equals dynamic viscosity, Cp equals specific heat capacity, K equals thermal conductivity. Physical meaning. Prandtl tells us, does momentum spread faster than heat, or does heat spread faster than momentum? When Prandtl is less than 1, heat diffuses faster than momentum. Example, liquid metals, Prandtl approximately 0.01. Excellent heat conductors. Thermal boundary layer is thicker than velocity boundary layer. When Prandtl equals approximately 1, heat and momentum diffuse at similar rates. Example, gases like air, Prandtl approximately 0.7. Balanced behavior. When Prandtl is greater than 1, momentum diffuses faster than heat. Example, water, Prandtl approximately 7. Oils, Prandtl approximately 100 to 1000. Velocity boundary layer is thicker than thermal boundary layer. Why does this matter? Prandtl number appears in every convection heat transfer correlation. It's essential for calculating heat transfer coefficients in forced convection. Verification, check that it's dimensionless, nu meters per second squared, divided by alpha meters per second squared, units cancel out.